Hello, this is Mac O'Leary, and this is lab report number 4 for Physics 2211. So this lab, we simulated a spring mass system in order to gain insights into the use of the energy principle, showing that energy remains consistent. In order to do that, we used the tracker application and GlowScript Python, and the simulations showed good accordance with experimental data. So the main idea of this lab was to measure and track an object moving in 2 dimensions, being acted upon by a spring and gravity, and we would use the energy of both of those things, so gravitational potential energy and spring potential energy, as well as kinetic energy, and then use that to show. We assume that the mass of the object, the spring constant, and all relative lengths are consistent. We also assume that there is no distortion due to the camera lens, as the lens is far enough away from the experimental setup. The system in this instance is the ball, and the surroundings are the earth, which exerts a force of gravity, and the spring, which exerts a spring force. Air resistance is assumed to be negligible. In order to do this, we first used a video that was provided, and then we plugged that video into the tracker application. From there, we went frame by frame and tracked each position of the mass at a certain point. This was then exported as a CSV file to be used with the code. So, coding for this lab involved a model with 240 iterations per second that calculated forces of gravity and the spring. It also calculated the energies for gravity, spring, kinetic, and total. Visualizations involved the mass, the spring, the origin, and the trail, and also the measured mass. The initial velocity was drawn from the spreadsheet data, and a CSV upload was used to show the measured position. The 4 types of energy that were calculated were then visualized on a graph simultaneously. The data for this experiment showed good accordance with the model. So, as you can see here, the blue, which is the calculated by the model, showed good accordance with the red, which is the measured, and that remained pretty consistent throughout the experiment. So that was very good. And then the energy principle was confirmed as a valid method to predict the state of the system because that remained consistent and we were using energy to calculate that. So what does it mean? There were 2 main questions that we needed to answer with this lab. So the first one was, is the energy principle satisfied? And that would be yes, because the energy principle would be that the energy of the system remains constant, and as you can see, this is the change in total energy, delta E, the orange line here, and that throughout the entire experiment just stays a flat line, which means that our energy, the total energy of the system, is not changing. The oscillations in the x and the y directions, do they have the same period? The answer to that is no, they do not, which you can tell because the track doesn't remain a constant straight line. But going through the spreadsheet data, you can see that the oscillation in the y direction has a period of 1.52 seconds, while the oscillation in the x direction takes longer at 1.73 seconds. This is likely because gravity does not act in the x direction, so there were more forces acting upon the mass in the y direction, including gravity and the majority of the spring force, as opposed to just a portion of the spring force in the x direction. In conclusion, this experiment sought to simulate a system while calculating instantaneous energies to show that the total energy of a system remains constant. This was expected to create a situation where the energy of the system would stay the same throughout the course of the experiment. The results of the experiment showed good accordance with the expected results, as the energy stayed constant and the simulated mass's trajectory matched that of the real mass. Thank you. One sec. I got it.